tell me the difference between a population and a sample? Sure.
Population is people that are being tested, and the sample is they derive a certain amount of people from the population.
Okay, I like the sample part. The population includes everybody that could possibly be tested for that situation, right? High school, I'm testing high school statistics kids to see their knowledges of statistics before they start class. So my population is in the United States. Every student taking a statistics class. Is it possible to test every student taking a statistics class? No. So I take a sample of those. So a sample is a subset of your population. And that's what I'm going to test. But you were really close on that. That was good. So a sample is just a subset of this. And so a sample comes from a population. It can be the whole entire population. It can. But a population is the big one. When you're looking to see if something that they gave you is a sample or a population, always say to yourself, are there more? I'm surveying nurses. I have 254 nurses to survey. Are there more nurses than that? So that's my sample. My population is all nurses. I'm surveying 32 NFA students. Sample or population? Sample. Do I have more than this many students? It comes from the population of all NFA students. So I'm looking for all possible things to take in, and from that, I'm taking a little portion of it. I'm taking a subset of that. So that's where sample comes from. The word parameter, most of the time you're going to hear the word statistic used. A statistic really refers to a sample, information that you pulled off from your sample. People use the word statistics like they use the word, I'll have a Coke. It used to be, I gotta have a Coke, whether it was Pepsi or Coke, you still got a cola. So now you have to say cola, I'll have a cola. So it's kind of the generic name. So you're going to hear a lot, everybody says statistic, regardless if it's a population or not. But technically, the easy way to remember it is P. A population, if something is stated about it, it's called a parameter. A statistic, if something is stated about it, it's from a sample, SS. Okay, so that's how we determine those two things. Regardless, you're going to look at statistics and say this is the statistic. Kind of like that generic name. So in a recent survey, 614 small business owners in the United States were asked if they thought their company's Facebook presence was valuable. 258 of those 614 respondents said yes. So, first of all, come to this number. 614 small business owners. Is that a population, a sample, or a statistic? A sample. Because where is my population? It's all small business owners. So if I can say there are more than that in the United States, we're automatically assuming in the United States, by the way, unless specifically say in the world or something, but most of the time we're assuming in the United States. So if I say 614 small business, if I could say there are more than that, this is a sample from my given population. This right here, 258, is my statistic. 258 out of 614 responded yes, said their Facebook presence was valuable. Facebook was valuable. said their Facebook page was valuable. So you're going to take the number that they give you. You're going to ask yourself, are there more? If there are, you're going to say, okay, then that's my sample. Now, sometimes you won't know. If I say I surveyed, I took a poll, I looked at 856 blue diamonds. I don't know if there are more blue diamonds or not, then it's going to tell you. But in a case like this, it's kind of generalized. You're going to say to yourself, are there more? So you'll see the more. Here's one of the ones that you'll eventually do. We'll just do these together today. The U.S. Department of Energy conducts weekly surveys of approximately 800 gas stations to determine the average price of gas of their regular gasoline. On December 10, 2012, the average price was $3.35 per gallon. Identify the population, the sample, and what does the data set consist of. So start with the number they gave you, 800 gasoline stations. Sample or population? Sample. Because are there more gas stations in the United States? Oh yeah. So sample is my 800 gas stations. Populations is all gas stations in the United States. So since they're giving me information about a sample, then I have a statistic. So my statistic is, on this day, the average price was $3.35 for regular gas. That's my statistic because it's a piece of information about my sample. Make sense? Okay. In the beginning, we're just going through kind of definitions and just how we define this. Populations and samples are really, really important. So now we're going to be asked to decide, does this piece of information, should we call it a parameter? Should we call it a statistic? A parameter is information about a population, P and P. A statistic is information about a sample, S and S. So the first one says, a recent study of approximately 400,000 employers reported that the average starting salary for marketing majors is $53,400. I have to ask myself first, what's with this? Is this a sample or a population? Well, is there possibly more than 400,000 employers in the United States? So that's what you have to ask yourself. So this would be a sample. Sometimes they will say all 400 or all of the, and they'll say that then you can assume it's a population. So a survey for a recent of these guys. So this is my sample. So therefore, the information that they're giving you is called a statistic or a parameter. A statistic. Good. Okay. The freshman class at a university has an average SAT math score of 514. So who are they talking about? At a specific university. Ah, so that's a population. So see the difference? That's a population. It's all the freshmen at that university. Not all the freshmen possible. So since they're talking about a population, what is this piece of information? A parameter. Good. Sometimes it's a little tricky to get there, and sometimes it will even use the word sample in a random sample of. In a random check of 400 retail stores, the Food and Drug Administration found that 34% of the stores were not storing fish at the proper temperature. Sample, because there are probably a lot more than this in the world, right, in the United States. So this would be what? A statistic. Okay. This is not your population, and 34% of it is not your sample. This is your sample. This is your information given about the sample. If it's given about the sample, it's a statistic. If it's given about the population, it's a parameter. P, S, and S. Okay. So you guys Think about this one for a minute. Read it and think about this one for a minute. Is that $5,150,694 a parameter or a statistic? Parameter. Because what?
It's all the 65 employees at that company.
Good. It's just the 65 employees at that company. That's very good. This is their population. So sometimes you gotta draw this out of this. Okay, see where we're going with this? Statistic with the sample, parameter with the population. Doing a little bit better. I shouldn't speak out loud. Okay, again, we hit this a little bit yesterday. There are two major branches. Our first, up to say chapter 4 or 5, goes through descriptive statistics. After that, we get into inferential statistics. Descriptive is just what we were doing. What describes this? What describes this population? What describes this sample? What is being said about it? What information are you giving me? It just gives you something about whatever it is you're looking at. Freshmen, all nurses, people with diseases, whatever it is you're looking at. So it just describes a piece of that. Inferential statistics involves using these descriptive statistics and other measurements that you might find to make an inference, to say something about your population. Probability is one of those tools that we're going to use in chapter 3 that gives us a little bit of insight into inferential. It's basically used to forecast, to predict. Probability is a prediction tool or a forecasting tool. What is the probability that something happens? Predict what will happen. Basically, right now we're just talking about chapter 1 gives us a lot of descriptive things. It breaks down our data into different areas, breaks down population sample, because that we're going to use that for the rest of this whole course. So we're going to decide which part of this study represents a descriptive branch of statistics. And what conclusion can you make? You can make an inference. It's an educated guess when you make an inference. It may not be exactly the reason why it happened, but you can make an inference about your information. Decide which part of the study is descriptive first. A large sample of men, so right away we know we have a sample, sometimes it tells you that, age 48, were studied for 18 years. For unmarried men, approximately 70% were alive at age 65. For married men, 90% were alive at age 65. So what part of this is the descriptive statistic? .48 is part of my describing my sample. So I could say that they're age 48. It could be a descriptive statistic. You're not wrong. It's a descriptive statistic. What else? Well, what about 65? 90% of them were alive at 65 for married men. That is the whole descriptive statistic. This whole line here is what I'm describing. This is my descriptive statistic. Why did I sample these men? What did I ask them? The reason they're all the same age, you can't do a survey and ask different men a question if they're not related. A population has to include all about the same type of, they would include all men that are 48 years old. And from that, I'm pulling out a little sample that are 48. I don't want men that are 58 in here. They're at a different thing. I want everybody that has a commonality. So this is describing it, and this is describing it. For my unmarried men, there's another descriptive statistic. We've surveyed these men, all age 48, and we found that for unmarried men, 70% were alive at 65. 90% were alive at 65 for married men. It's a big difference. So make me an inference. Tell me, what does that mean to you? You read this and you say, I say, wow, from 70 to 90, 20% more if they were married. So what does that mean to you? Give me one inference. If you're married, you live longer. Okay, what else could that infer?
If you're not married, you die quicker.
Well, let's kind of like repeat. Yeah, kind of. But so what does married have to do with anything? Think about something.
Because the women help the men live longer.
The women make the men happy and they help the men live longer. Yes, of course. The women do all the hard work and make the men very happy. So, but I mean, that's an inference. Do we know that to be a fact? No. Maybe the woman nags the crap out of the guy. You need to go to the doctor. You need to get that checked. You need to do this. You need to take your medicine in the morning. You know, so that we can infer that too. You know, we can infer that too. If we're interested, we could actually look to see who did this, what they were looking for, what constituted their survey. But all they did was find out if they were, you know, alive or not at 65. Okay, here's another one. In a sample of Wall Street analysts, the percentage who incorrectly forecasted high-tech earnings in a recent year was 44%. In a sample of Wall Street analysts. So is this obviously this is a sample, not a population, right? Because it says a sample. So this is going to be my descriptive statistic. The 44% forecasted incorrectly in the recent year. That's my descriptive statistic. Now, give me an inference. What about that? Do you find that alarming? They're analysts. They're Wall Street analysts. Shouldn't they be pretty spot on if you're giving them your money to invest? Mm-hmm. So give me an inference. What would cause this to happen? By taking economics?
It's not like stable.
What's not stable?
The stock market.
The stock market, the economy. In recent years, has our economy been very stable? It's been very unpredictable. So can I make that inference? I don't think that my Wall Street analysts are stupid. I don't think that they're not doing their job. I'm sure they are. They went to school for a long time. They've been working. They're hard workers. But the economy, I could say, well, the economy is very unstable. If you're taking economics now, you'll probably see a lot of these things in your economics class. So an inference we can make is we have a very unstable economy right now. Stock market, that's one of the ones that are very tricky right now. So take a look at this one, read it over, and we're going to discuss it in a second. So read it over. Probably would think so a lot of you guys could do. What do you think of this? Is this a statistic or a parameter? A statistic because what? 750 is a sample. Do we have more parents than that of kids that are going to college? Mm-hmm. So our descriptive statistic is this. 31% support their kids financially until they graduate college, and 6% provide financial support until they start college. So it seems that more people are providing support all the way through college. So can you give me an inference? Something you can infer from this information?
They
Yeah.
would be wealthier,
Who's wealthier?
like parents.
The parents could be wealthier. They're supporting their kids, or what? Think about when you go to college. Are you going to need financial help from your parents? Because what? Because it's expensive, and what are you going to be doing? Studying. Are you going to have a lot of time to get a high maintenance job there and support your own things? No. You're going to depend more on financial support. I really think that number's kind of low. And it kind of surprised me. Did anybody get kind of surprised that only 6% support until they start college? That kind of was a little bit.
After high school.
Yeah, until they start college. Maybe there's a gap between high school and college. I don't know. But I think 31% is fairly small. My kids went to college. They're out of college, and I'm still supporting them, but still helping them financially. So, these are descriptive statistics that you have to digest. You have to think about, and you may not know the real reason that these happen, but you can make an educated guess. Put yourself into that position. Make an educated guess of why this happens. Good? Okay, so we did it. We went through a whole unit.